Navigators, this is 11-2, volumes of prisms and cylinders, day 1. I can use the properties of prisms and cylinders to calculate their volumes. Let's take a look at a right rectangular prism. Notice that it has two bases that are parallel to each other, and all cross sections will be the same area, and it's standing straight up, making a right angle. Oblique triangular prism again has two bases that are parallel to each other, and all the cross sections are equal in area, but the height, the edge right here is not making a right angle, but it still has a height. Cavalier's principle says this: if the first stack here of cards is making a right prism, the second stack is making a prism too, but it's oblique. Oblique is that the lateral faces right here are not rectangular. It's making an angle right here. But every index card has the same area and represents the same cross section of the prism. If each card, each cross section has the same area and the heights are the same, then we say the volume of the two stacks are the same because the sum of the areas of the cards are the same. This is called Cavalier's principle. Again, if two three-dimensional figures have the same height, so if all of these have the same height, and if their cross sections all have the same area, then the conclusion is the volumes are all equal. The idea of a volume of a prism is the idea of a stacking technique. What we want to do is count how many cubic units are fitting inside a prism. We can do that by taking a look at the lower level, the bottom here, or it can be anywhere. But if you find the area of this level right here and then multiply it by how many levels there are, that's the stacking technique. So what we're doing here is we're finding the area of the base area, and that's this green part right here, and then we're timesing it by how many stacks there are, or how many stories there are. That's the height, and when we multiply that, we end up getting the volume. The volume is equal to the area of the base times height when we're talking about a prism. A prism has two bases that have the same area and are parallel to each other. So the bases can be a triangle. We may be using the triangle formula to figure out that bottom part of the stack. Let's go ahead and practice. I am going to find the volume of this prism, and I'm going to use this as the base, and then this base will be parallel to it. So the volume is equal to the area of the base times the height. Now the base in this problem is a rectangle, and it's kind of a nice idea to draw the rectangle. This is a 7 by 4, and so altogether that'll be 28. And the number of stacks, that's this guy right here, is 3. And so the answer is 84 inches cubed. That's how many little cubic units there will be. I'm going to do the problem again, but this time I'm going to consider this is the base. And so to be parallel, it'll be this. So now I'm going to work the same figure, but this time my base is this green part, which is 4 times 3. So the area of the base will be 12. Now this will be considered the height. It's the distance between one base to the other. And the answer is 84 cubic inches. So remember that the bases have to be parallel. On a rectangular prism, you can choose the top or the bottom, or the two sides, or even the front and the back. Now in this particular problem, we have no choice in the matter. This has to be the base. And these are the two parallel ones, and we have to choose those. So volume is equal to the area of the base times the height. Let's go ahead and draw the base, and the base is a rectangle. It's a 9 by 8. So that base will be 72. Now the number of stacks is 12. That's the height. And when we multiply those two numbers, 72 times 12 is 864, and that'll be cubic centimeters. All right, now let's go ahead and take a look at where the bases are other than a rectangle. So this base and this base are parallel, and they are triangles. So volume is equal to the area of the base times the height. the base is a right triangle, and it looks like this is 3 and this is 4. So this is area, or the area of the base is 1/2 little b times h, and the base is 3 and the height is 4, or we can reverse it. So the answer to that is 6. The height is how tall the stacks are, and that's 5, and so the answer is 30 cubic miles. Now in this case, the bases are not on the top and the bottom. Notice that the bases are in the front, and if you want to see the other base, it's just not showing up, but the other base is back here, and they are parallel to each other. So they look something like this, 5 and 6, and here's the right angle. So the area of the base is the formula for a triangle, and that'll be 1/2 times 5 times 6, and that'll be a 15. So volume will equal the area of the base times the height. The base will be 15, and the number of stacks is right here, 20. And so the answer is 300 cubic centimeters. Now let's take a look at another prism. This prism is not on the top and the bottom. Let me go ahead and go to the next screen. There's another trapezoid in the back, okay? So it's not showing up, but the other trapezoid's in the back. So I'm going to go back to this one. This is the area of the base. It is a trapezoid. So we want to figure out the volume is equal to the area of the base times the height. Our base is a trapezoid, and the formula for a trapezoid is 1/2 height times the sum of the bases. And the height is right here, 8, and one base is 6 and the other base is 12. So this is 1/2 times 8 times 18. I'm going to do a little reducing, and then I'm going to multiply 2 carry 3, 72 is the area of the base. So I'm going to put it up here, 72, and the number of stacks is right here. That's how the stacks are going, times 1, and so the answer is 72 cubic inches. All right, here's another prism, and again, a more complicated base. This base is this figure, and there's one in the back as well. So the volume is equal to the area of the base times the height. Now, let's take this base, and I'm going to erase this so I can kind of, erasing right here. All right, so I'm going to divide this into 2 rectangles. So this is 7 times 12, so this part is going to be 84. And if this is 9, this must be 3, because we have to make it 12 here. And if this is 7, then this is going to have to be 8 to make this 15. So this is 3 times 8, and that's going to be 24. So we're going to take these two areas, add them up, and the area of the base will be 108. So I found the area by doing a composite. So this is 108, and the stacks are 20 high. And so this answer is 216 with a 0 centimeters cubed. One last problem. Let's go ahead and find the height. So the volume is equal to the area of the base times the height. We are given the volume. So this is 2304. The area of the base, remember this base is a rectangle, and it's 16 by 6, which is 96. And we're looking for the height, which happens to be u. We're going to use algebra to solve for u. 2304 divided by 96, and the answer is 24. 24 equals u. So this will be a 24, so that when I find the volume, I will get this number.